So a very early first view of long-term memory came from a researcher, Hyde, in 1949 in the form of his consolidation hypothesis. Now, Hyde adopted this very traditional view that you rehearse information in short-term memory. The memory trace is very fragile, but the continued rehearsal will send it to long-term memory, and then it becomes a lot more permanent and durable. Now, Hyde went one step further and actually said there was a physiological change to the memories once they transfer to long-term memory. So there's actually change in the brain structure, and that's why the memories are more solid or more permanent, or they're consolidated, as it were. And there's no empirical support for Hyde's view, but that was an early view that I thought I'd mention. Another early view of long-term memory comes from Craig and Lockhart, and this is the levels of processing hypothesis. And essentially, Craig and Lockhart said that there's two types of rehearsal. There's the maintenance rehearsal, which is very shallow, a shallow type of rehearsal, and it doesn't necessarily mean that the information that you rehearse there is going to transfer into long-term memory. It's more probably about just keeping the memory trace alive, like keeping a phone number alive until you've dialed it, something like that. And then there's elaborative rehearsal, and this is much more involved, in-depth processing of the information. And it's this type of elaborative rehearsal which allows information to really set itself and concrete itself in long-term memory and be much more permanent and durable. So essentially, the upshot of the levels of processing hypothesis is that the deeper you process, the more durable your memories are, the greater the retention. And there is some evidence to support this idea, and it comes from Hyde and Jenkins. So what they did is they got participants to look at some items, some words, and for one group of participants they just had to do shallow processing, just say, check for the letter E in each word. Another group of participants again had shallow processing, they just had to count the letters in each word. And then a third group of participants had to actually rate the words in terms of their pleasantness. So that was more of an elaborative type of encoding, type of processing. And what you can clearly see that is as the encoding, or the depth of the encoding increases, so does the recall. Okay, you can clearly see an increase there. So that's quite simple to understand. However, the levels of processing hypothesis is okay, but it didn't really fully constitute what we'd say call a full-blown theory. And also this idea of depth of processing is quite vague, and a lot of memory theorists became dissatisfied with it. They wanted a more rigorous definition of what do you exactly mean by depth. I mean, you can clearly see a difference in depth in a sort of a simple experiment, such as Hyde and Jenkins. But in everyday life, when you're using memory, how do you differentiate deep processing from shallow processing? I just want to talk a little bit now about the use of mnemonics. So a mnemonic system is really a conscious strategy or technique whereby you can improve your memory. And mnemonic systems have been in existence for thousands of years. So if you think in ancient societies, before the advent of writing, or even when there was writing, but the only implement you had was, a sharp stone and a stone tablet, the ability to be able to remember a lot of information and record it and have it mentally stored was a prized skill, and you could earn a lot of money and credence from having that. So mnemonic systems were developed, a lot of years ago, and they're still with us today. And an essential underlying principle of a mnemonic system is rather than simplifying the to-be-remembered information, you elaborate it and try and integrate it into your existing knowledge. And the more you can fit it with your existing knowledge, the better or more successful these mnemonic systems become. So I'll give you an example of a few mnemonic systems here. So we've got the method of loci. So loci is the plural for locus, which is the Latin word for location. So what you do with this system is really you associate the to-be-remembered items with a geographical location. But that location has to be very familiar in your long-term memory. So it might be, I'd say, a routine walk from your home to work each day, or it could be a walk around the house that you live in. It needs to be very firmly in your mind. And then you associate the to-be-remembered items with different locations on that route. So, for example, if I want to remember a shopping list, cheese, milk, eggs, soy sauce, lettuce, I could associate each of those items with a particular room in my house. So, for instance, the cheese in the hallway, milk in the bathroom, eggs in the kitchen, soy sauce on the dining room table, and lettuce on the armchair in the lounge, that kind of thing. And then when I get to the supermarket, to remind me of my shopping list, I take a walk around my house into each room, and each room should provide a cue, a stimulus to the actual item to be remembered. Now, this doesn't particularly work when you've only got a list of 5 items. Probably everyone's thinking, well, it's just easier to remember the 5 items rather than the rooms and then make that association. It seems like hard work. But when you have long lists of information, a lot of information, these mnemonic systems, particularly the method of loci, they do work. And apparently, I think it's Dominic O'Brien, he's about the 8th world memory champion. He uses this method of loci, and it does work, but you need to be practiced at it and train your mind. And it only works when there's lots of information. It becomes effective. Another example of a mnemonic system is the peg word method. And this involves associating the to-be-remembered items with a set of mental hooks or pegs. And these are kind of like usually nouns, something that's highly visible. And the peg word method is thought to be very good if you want to remember the order of things or the sequence of things. So what you do is you have something that you are very familiar with in your long-term memory. So I don't know, the alphabet or the numbers 1 to 100. And then you associate your peg word with a number or a letter of the alphabet. So for instance, I could associate the word bun, that can be my peg word. I associate that with 1 because they rhyme, and then I associate the word shoe, which is my peg word, with the number 2, and then tree with 3, door with 4, hive with 5. I mean, you make up your own examples. These are just taken from your textbook. And then you associate your to-be-remembered information with your peg word, and then you count when you want to recall your list. And these different associations give you cues. Your peg word gives you a cue to your to-be-remembered item. So, for instance, I want to remember my shopping list. I'm in the supermarket, so I imagine my first peg word, which I know is going to be bun, because it rhymes with 1, and then I imagine the cheese with the bun, then I imagine the milk with the shoe, and then the eggs with the tree, the soy sauce with the door, and the lettuce with the hive, which rhymes with 5. And what you can do, again, it only works when you've got lots of information, but you can almost train your mind to be like a mental filing cabinet. And these strategies do work, but again, you have to be trained at it. A final example of a mnemonic system is a narrative story. Now, the idea here is your to-be-remembered information needs to be integrated into a meaningful, cohesive story. That's meaningful personally to you. And even people who aren't trained in mnemonics find that when they use this system, yeah, it improves their recall and their memory. Okay, so next we'll talk about organisation of long-term memory. So it's not the case that your long-term memory is this vast warehouse that just takes in all information, all your experiences and everything you've learned throughout your life. It's thought that long-term memory is made up of separate systems and types of memory, and they have different functions and they function in different ways, as it were. So first of all, there's been some divisions made by previous researchers, and one of these divisions is your explicit versus implicit memory. Now, explicit memory is where you make a conscious effort to recollect some information, to recall some information. So, for instance, it could be, an example could be, you're trying to remember on this day, I've got a dentist appointment at that time. You're making a conscious effort to recall some information that you remembered encoding at the time. Now, the converse is implicit memory. Now, implicit memory is learning that takes place that you're not really conscious of, you're not aware of. So, for instance, you could have a driving lesson. Now, remembering that specific driving lesson would be an example of explicit memory. But your improvement in driving during that lesson would be an example of implicit learning. Because obviously the more you drive, the more automatic your skill becomes, the more you improve. But you're not necessarily fully aware of how you're improving and when you're improving. You're unaware. And an example of implicit memory is procedural memory, your how-to knowledge. So things like learning to drive, that becoming automatic, learning to ride a bike, touch typing, these are all examples of procedural memory or implicit memory, learning without actually recognising that you're learning. And a lot of priming studies look at things like implicit memory. Now, episodic memory, that's an example of explicit memory. So episodic memory is your memory for your personal experiences and events in your life, your autobiographical memory. So again, it takes a conscious effort to recall these events. So that's why it comes under this umbrella term of explicit memory. So episodic memory is an example of an explicit memory. Semantic memory, again, is another example of an explicit memory. But semantic memory, you don't necessarily have to recall an event. Your semantic memory is more about your conceptual understanding of the world, your generalised knowledge. So, for instance, I could say to you, wrenches are pets or tools. You would know that a wrench is a tool and not a pet. That's an example of you using your semantic memory. It shows your general knowledge, your general level of understanding of the world. Okay, we'll talk about remembering now. Now, you can have all this information in your long-term memory, but it's not necessarily the case that what you've remembered is an accurate representation of what exactly happened. And this is something that Bartlett looked at, a very early researcher, back in 1932. He saw remembering as almost a creative process, and it's not an exact science either, according to his view. And he's quoted as saying, remembering is an imaginative reconstruction, thus hardly ever really exact. And the way that he explored this idea of memory being creative and a reconstruction is that he told participants a tale, an American folk tale, which had quite a few sort of unusual and peculiar kind of like parts to it, sequences to it. And then he got participants to retell the story on different occasions. And what he found was that on each different version of the participants retelling the story, they changed the story. And they changed it almost, particularly at the parts where there were peculiar events occurred. So they almost like changed it to make it make sense and make it fit in with their own expectations of what they thought reality should be like. So based on this research, Bartlett argued that memory is not exact, and it is this creative process. We reconstruct our memories. So memories aren't something that are just static and stay the same. They're modified in light of new information, and across time they change. So they're possibly not that reliable. And this relates to the work of Elizabeth Loftus and her colleagues. And her work really did highlight this fact that our memory for past events can be very pliable and malleable, and it can be modified given like later events, recent events. So she ran a whole series of experiments in the labs that were highly controlled. I'll just describe one to you. She presented participants, she let participants watch a video of two cars crashing. And then after the video, participants at a later point were asked, to estimate at what speed the cars were travelling. Now, just subtly in this question, she varied the potency of a verb. And the way that she said it was, what speed were the cars travelling when they either contacted, hit, bumped, collided, or smashed with each other. So it's just one word that changed, that was all. That was the potency of the verb. And what she found was, if you look at the diagram here, that those participants as the potency of the word increased, so did the estimation of the speed. And you can see a positive linear correlation here quite clearly. So when the participants heard the word smashed, they had the highest estimation of how fast the cars were going. So you can see how memory, and everyone saw the same video and the cars were travelling at exactly the same speed. So you can see how some post-events, just a subtle leading, a verb in a leading question can change and modify people's memory for events. And this has very important ramifications for eyewitness testimony. Sorry. And to the point, with one point actually where psychology has actually had a practical impact on the world. So it's changed the way that the police interview witnesses now. And there's such a thing as called a cognitive interview, and it's kind of like made and designed so that you only have open rather than leading questions. And there's other strategies in there as well, based on Elizabeth Loftus's research. Okay, we'll talk about state-dependent memory now. So this is where, if learning takes place in a particular environment, and then that same environment is reinstated when you're reproducing that or recalling that information, recall is going to be better than if the environment is different to when you were learning. And this rule applies both to your external environment and also your internal environment, how you're feeling in terms of emotions or your physiological state. So an example of state-dependent learning or memory with an external environment, there was a study carried out by Godden and Baddeley back in 1975, and it was about divers. Now, deep sea divers have to undergo a lot of training, so obviously it's going to be practical that they undergo this training on land rather than underwater. But they often have to apply this training and apply these skills underwater. And this is what made Godden and Baddeley sort of like look at this, because they felt that training is more effective if it's given to the place where you're going to reproduce it. But anyway, they kind of set up a very simple experiment to kind of like illustrate this. So they got these deep sea divers just to learn a list of words, either underwater or on land. And then they got them to recall this list of words, again, either underwater and or on land. And they found that recall performance was far better when the location matched the location where they were learnt. So better recall underwater when the recall was underwater, and better recall when the learning and the recall was on land. But when you crossed, learnt underwater, recalled on land, performance dipped. Okay? So you need to match your learning and recall environment. And the same applies to your internal environment. Bauer has done some research where he's given someone something to learn whilst they're in a particular emotional state, under hypnosis, you induce people into certain types of mood. They'd learnt something, and they can only recall what they learned once they're induced into that same hypnotic state again. And also other researchers have done some research where someone's kind of like is aware of something or had an experience while they're in a drug-induced state, and then when they come round they can't remember, and they can only recall that experience when they're again in that similar chemical or drug-induced state. So again, there needs to be a match in terms of your internal environment, and learning and memory is always enhanced when you've got that environmental match, whether it's internal or external. Final topic is amnesia. Now, amnesia is caused by some form of brain injury. Common causes are kind of like trauma to the head, car crash, stroke, surgery, or long-term alcoholism. Now, a main type of amnesia is anterograde amnesia. Now, this is loss of memory for what happens after the event that's caused the trauma. Now, the famous case of anterograde amnesia is the patient HM, and these patients are actually given a code name to sort of like preserve their identity. I've already talked about HM, but he had this anterograde amnesia, which was brought on when he underwent surgery to cure his epilepsy, but then that damaged his long-term memory. So HM, he couldn't lay down any new memories. He could remember everything before his surgery, but he couldn't remember anything afterwards. He couldn't lay down any new memories. So any new experiences he had after his surgery, he could not remember. So for example, he had a favourite uncle who died after surgery. But every so often, HM would ask his relatives, I haven't seen this uncle, when's he going to visit me? And the relatives would have to say to him, your uncle's died. And HM would react with the same kind of emotional distress and upset as if he'd been told for the first time. And he was told so many times over and over again. So you can see, you know, it's very, very difficult to live with this type of memory loss. Another main form of amnesia is retrograde amnesia. And this is failure to recall events experienced before the trauma or the onset of the amnesia. Now, a famous case or a famous amnesic patient is the case of Clive Waring. Now, Clive Waring was a highly intelligent man. He was a really successful musician, but he contracted a virus which normally only causes cold sores, but this virus went to his brain, and he ended up with both anterograde and retrograde amnesia. And because of that, all he had was just moment-to-moment consciousness. He just had his short-term memory, which at a maximum is going to only last for about 20 seconds. However, some of his long-term memory abilities were spared. He could still play the piano, could still conduct an orchestra, so his procedural memory was spared. But everything else, he couldn't lay down, couldn't do any more learning, he couldn't remember anything before the virus attacked his brain either. And Clive's condition meant that he had this constant feeling of just waking up. And you can see this if you have a look at his diary. I hope you can see it there. So, you know, at 10:08, now I am awake, first time. And then 10:13, you know, just a few minutes later, now I am, you know, awake again for the first time. It's over and over again. So you can see his torment, really, that you couldn't understand.